That squirrel sitting on your fence right now, flicking its tail and making that sharp little barking sound. Do you actually know what it's saying? Most people think it's just noise, a skittish little rodent reacting to something random, instinctive, forgettable. But that sound has a structure. That tail movement follows geometric rules. And part of what that squirrel is broadcasting to every animal in your yard is a detailed report about you, your intentions, your threat level, and whether or not you can be trusted. Scientists have spent decades decoding this, and what they found goes far beyond anything most people would expect from an animal the size of your fist. Today, we're breaking down 8 things squirrels are actually communicating to each other and directly about you. And number 6 might make you rethink every moment you've ever spent near one. Have you ever heard a squirrel make that rapid, sharp little yelp, almost like a tiny dog barking? When you walk past a tree, you probably assumed it was just startled, a noise, a reflex. That's not random noise. That's a precision alarm system with its own vocabulary. Researchers studying eastern gray squirrels documented something remarkable. That short, sharp sound, called a cuck, is specifically engineered to be easy to locate in space. It's a broadband signal, and it's firing deliberately, not randomly. When a squirrel sees a ground level threat, a cat, a dog, or a human crossing the yard, the cuck rate spikes. In some encounters, the call rate for a ground threat is nearly 3 times higher than what the squirrel produces for an aerial predator. That difference isn't noise, that's coding. What the squirrel is doing with each cuck is publicly broadcasting your position to every other squirrel in the area. It's announcing, I see you, and now everyone else does too. And here's the part that changes everything. By exposing this position, the squirrel removes your greatest advantage, surprise. Most predators lose interest the moment they realize they've been seen. The cuck isn't fear, it's a calculated counter move. When that squirrel barks at you from the fence, it isn't panicking, it's neutralizing you. If you've ever stayed too long near a bird feeder in your yard, you may have noticed the squirrel's sound shift from that sharp bark to something longer, more rasping, a slower, drawn out call that almost sounds like it's scolding you. That sound has a name too, the qua, and it means something entirely different from the cuck. The cuck is detection. The qua is commentary. After roughly the first 30 seconds of a threat encounter, if you haven't left, the squirrel begins folding in quas. The call lengthens. The tone changes. Pathologists describe it as a vocal reprimand, the squirrel signaling to the entire yard that you are still there, that you haven't moved on, and that the area remains under active surveillance. Think of it this way. The cuck is a news flash. The qua is the ongoing broadcast. For the squirrel, this distinction matters enormously. Other animals in the yard aren't just listening for danger. They're listening for whether the danger is passing or escalating. The shift from cuck to qua tells them, stay alert, this isn't over. If you linger near your squirrel's favorite spot and it starts throwing quasses at you, it isn't afraid of you. It's narrating you to its entire neighborhood in real time. If that squirrel on your fence could hit subscribe right now, it would. Because understanding what wild animals are actually saying about us, that's the kind of thing they'd want you to know. Hit subscribe if you want to keep going deeper into the hidden language happening right outside your window. Here's where the squirrel's vocal system does something genuinely extraordinary. When a hawk circles overhead, the squirrel doesn't bark. It doesn't throw rapid cucks into the air. It makes a completely different sound, a soft, clear whistle that rises quickly and falls slowly. Scientists call it a moan, and it seems almost too quiet for an alarm. That's exactly the point. Here's the physics. Broadband sounds, like the cuck, are easy to locate in space. That's useful when you want others to triangulate a threat's position. But tonal sounds, with no sharp transients, are almost impossible for aerial hunters to pinpoint. A hawk moving at high speed uses sound to zero in on prey. The moan gives it nothing to work with. So the squirrel solves an impossible problem. It needs to warn others about a predator that can hear and track sound without revealing where the warning is coming from. The moan is a signal specifically designed to survive its own transmission. What this means for your yard, the quiet, almost musical whistle you might hear when a bird of prey passes overhead, isn't timid. It's the most sophisticated call in the squirrel's vocabulary. It's a system that broadcasts danger while simultaneously disappearing from the airwaves. Most people look at a squirrel flicking its tail and see agitation, maybe nerves, maybe attitude. That tail is a high bandwidth visual communication channel with its own grammar. When squirrels call out alarm sounds, they almost always synchronize the call with a tail movement called flagging, a rapid oscillation that amplifies the signal visually. The movement catches the eye of other squirrels who might not hear the call over traffic or lawnmower noise. More importantly, it tells them which direction to look without forcing them to make direct eye contact with the threat themselves. There are rules about curvature and position that predict dominance and aggression between squirrels competing over your bird feeder or peanuts. A sharp, tense angle at the base of the tail signals high probability of an advance. The location of the fold, whether near the body or near the tip, communicates whether the squirrel is asserting dominance or issuing a warning. Squirrels at a backyard feeding station can resolve disputes over food entirely through tail geometry without a single physical confrontation. They read each other's body architecture the way you'd read a facial expression. But here's the counterintuitive rule. Against aerial threats, the tail goes completely still. Against a hawk, all flagging stops. Because the same movement that warns a squirrel neighbor also alerts a raptor. The squirrel switches off its most powerful tool when using it would get it killed. There's one tail movement that almost every backyard observer misreads completely. You've probably seen it, a squirrel that expected food from a familiar spot. Maybe you forgot to refill the feeder, or it knocked an acorn off a branch, and then produces a rapid, spasmodic twitch. You probably assumed that was an alarm signal, a sign it was spooked. That isn't fear, that's frustration. Researchers at UC Berkeley documented this behavior in controlled conditions. Squirrels trained to expect food from a container and then denied it when the container was locked, produced a distinct tail movement that was measurably different from alarm flagging. The rhythm was different. The context was different. The trigger was different. The researchers compared it to a person kicking a vending machine that swallowed their money. When a squirrel's environment fails to produce the outcome it predicted, When the physics of its expectations breaks down, the tale becomes a readout of cognitive error. It's a physical expression of this wasn't supposed to happen. In your yard, if a squirrel that you've been feeding starts producing that rapid, erratic twitch after finding an empty dish, it isn't afraid of you. It's expressing the squirrel equivalent of serious. These are not creatures operating on pure reflex. They track predictions about their environment and respond when those predictions fail. Here is the discovery that upended what scientists thought they knew about how squirrels assess danger. After a scare, say a hawk call or a sudden disturbance, squirrels enter a state of sustained vigilance. They freeze, scan, and delay, returning to normal behavior. That part was expected. What wasn't expected, what actually brings them back. A 2019 study published in PLOS ONE played different sounds to squirrels after inducing this high alert state. One group heard the relaxed conversational chattering of songbirds, the casual, ambient vocalizations birds make when nothing is threatening them. The other group heard silence. The squirrels that heard birdsong returned to feeding significantly faster, reduced their scanning behavior, and resumed normal activity much sooner than those that heard nothing. Silence for a squirrel is not reassurance. Silence is terrifying. It means every other animal in the area is also hiding, which amplifies the perceived threat rather than dissolving it. The casual chatter of birds is the squirrel's all-clear signal. It's environmental confirmation that other species with different vantage points and different sensory systems, have collectively concluded the danger has passed. Your yard's sparrows and finches and robins chattering through the afternoon aren't just background noise to the squirrel at your feeder. They are its real-time safety infrastructure. Every warble is data. Every song is a vote for coast is clear. This is why a quiet yard after a disturbance keeps a squirrel on edge far longer than a yard full of ordinary bird noise. The squirrel is listening for the verdict of a multi-species jury, and silence means the jury is still deliberating. Squirrels don't just react to your presence. They have built specific behavioral protocols around human behavior, and the precision of those rules is unsettling. Studies show that a squirrel is 40% more likely to flee if a human walking toward it is making direct eye contact, compared to a human walking at the same speed but looking to the side. The direction of your gaze changes their threat calculation, because in nature, predators that are looking at something are about to do something about it. There's also what researchers call the sidewalk rule. If you stay on the paved path, the squirrel often ignores you entirely. The moment you step onto the grass and move in its direction, flight probability increases to 90%. The surface you're walking on communicates your intention. Pavement is predictable. Grass means approach. These aren't random thresholds. They're internally consistent rules squirrels apply across encounters. They have modeled your behavior well enough to derive context from it. The squirrel in your yard isn't just watching you. It's running a continuous prediction about what your next move means. And the rules aren't uniform. Research suggests that squirrels may recognize individual humans, particularly those associated with food, using a combination of visual cues like gait and silhouette and olfactory information. If a squirrel in your yard approaches and watches you without calling alarm, it isn't asking for food in some passive way. It's conducting a cognitive assessment of your identity based on previous interactions. It already has a file on you, and it's checking whether today's version of you matches what it's recorded. This is the one that stays with you. After everything, the alarm architecture, the tail grammar, the eavesdropping on bird song, the 40% gaze effect, the individual recognition, there are moments in a yard that don't fit any of the threat categories. A squirrel that approaches, that sits close, that looks at you steadily, without flagging, without cucking, without flinching toward a tree, just watching. It isn't asking for food. It isn't confused. It has already run the assessment. It already knows your gait, your silhouette, your pattern in that space. It has cross-referenced you against its records and found no threat signal worth broadcasting. What you're looking at in that moment is an animal whose entire biology is tuned toward survival, whose cognitive resources are devoted to continuous threat evaluation, and it has decided you don't require any of it. Not because it's been tamed, not because it's forgotten what you are, but because it has built enough data on you specifically to extend something that, in the architecture of a nervous system, functions very much like trust. For an animal that lives inside a constant calculation of risk, choosing to sit near you and watch you without a single alarm note, that isn't indifference. If you've ever had that moment in your yard, you already know what it felt like, and now you know what it meant. You were in its file, and you passed. If you start paying attention to these signals, the rate of cucks, the geometry of the tail, the presence of birdsong after a scare, the direction of its gaze when it looks at you, the yard changes. It doesn't take long. A few days of watching with this framework, and you'll notice things you couldn't see before. The alarm that changes pitch when you move, the tail that stills when a hawk goes over, the squirrel that approaches you differently than it approaches anyone else. They've been running this system the entire time you've been out there, broadcasting reports, reading your gaze, cross-checking your intentions against a behavioral model it built from watching you specifically. They've been talking this whole time. Now you finally speak the language.